so you're doing question 17 from page 142. And we're doing relating factor and standard form, grade 11 mixed. Okay. They've given us a question, stainless steel gateway arch in St. Louis. They've told us that the arch on the left side, okay, so we'll say left side to the right side, let's just say it's right to the end here, is a difference of 192 meters, correct? Okay, so what that means is the difference here, from there to there, it's 192 meters. So let's give them actual x-intercepts. What can we give the two x-intercepts? What can the points be?
0, 192.
Yeah, so we have 0 and 0 as a coordinate. And what will this one be?
0 and 192.
Just the other way around. 192 and 0, right? Because the x always comes first. So x and y, x and y. The other thing they've told us is what? Well, we already know a y-intercept because it's at 0 and 0. We've set this up on the graph, so we're putting a graph over this. It says the arch is 192 meters high, and they said it's a parabola shape, right? Or parabolic shape. So in other words, whatever it is, that wasn't very well drawn, the highest point, let's assume it's somewhere here, this is the middle. This is 192 meters high. We don't know the x value, but we know the y value of the vertex is 192 meters high. So we have some shape that goes up, curves, and comes down. Okay, not perfectly drawn. So we need to find an x value, and we have a y value. Okay, we also have what? The two. Well, we have part of the vertex. What are these things called? Okay, so these are our two x-axes, right? Because that's where it's crossing the x-axis. So these are x-intercepts. So we have enough information. What form do we want to put this equation in? Factor, that's right, because a factored form will tell us x-intercepts, right? So our factored form, which we have here, we're going to work with that to start. Our factored form is y equals a x minus r x minus s, right? Well, what are our r and s values?
192 and 0.
Okay, so we'll call this s and this r, okay? So we know r is equal to 0 and s is equal to 192. So let's plug those values in, okay, for the r and the s. Does it make sense so far?
Yeah.
Y is equal to a. Our r value is 0, so x minus 0. X minus 192. We have that much information so far. Okay. Are those the only two coordinates they've given us? Okay, so we have part of the information here. Problem is we still have three variables, an a, an x, and a y. Okay. We're not going to get the a by looking at this. But we can find an x and y value. In fact, we already have part of one. The vertex. We know the y value is 192. We need to find the x value. Do you know what the formula was to find the x value of the vertex when we have two x-intercepts?
R plus s divided by 2.
Excellent. We know that we need to find r plus s divided by 2. That gives us our axis of symmetry, AOS, or the x value of our vertex, right? So our r value is 0 plus 192 divided by 2 equals, we'll put x here, okay, because that's the x value of our vertex. We get 192 divided by 2 is our x value. Our x value is 192 divided 2. What'd you get?
96.
Great. So we know the vertex, or the highest point of this, is now at 96 and 192. So what that is I now have an x and a y value I can plug into my factored form. So in other words, I can plug something in for the x's and the y, and then solve for our a. Okay? So our vertex let's put it on top here. Vertex is at 96 and 192. So I'm going to plug this in for my x and this in for my y. So my y value is 192 is equal to a. X is 96 minus 0, that's a 9, okay, times 96 minus 192. Now the only variable we have left is our a, and we can solve this algebraically to solve for a. Okay, so let's walk through this together. 192 is equal to a. 96 minus 0? 96 minus 192? Yes, good. Let's just double check. You're very right, because it's halfway in between, so it'll be negative 96. So we have negative 96 times positive 96. So we still have 192 is equal to a times negative 96 times positive 96, negative 9,216, right? Okay. Now that we have that, I have to isolate a, so I have to bring this negative 9,216 to the other side. How do I do that? Yeah. I want you to notice something. This says a times that. That's right. We're going to need to divide this. So it becomes 192 divided by negative 9,216 is equal to a. So 192 divide 9216. We're going to round our a value, okay? Negative 0.02. We're just going to say negative 0.02, okay, as our a value. Now, what that's given us is a factored form, right? Y is equal to negative 0.02 x minus 0. That was our r value. X minus 192. This is what form?
This is factored.
Yeah, factored. What's the question asking us? Which form to put it in? Standard. So what do you have to do next? So we're going to expand and simplify. I can't simplify that bracket, so I'm going to. We're going to get y is equal to negative 0.02. X minus 0 is just x, okay, times x minus 192, okay. Now, a multiplication rule is it doesn't matter what order you multiply things in, just as long as you multiply them. So let's just work with this. This says negative 0.02 times x. So what number is that going to become?
Negative
0.02x times x minus 192. Okay. Now what do I do?
multiply 0.02x to the other bracket.
By both numbers, right? We're distributing it inside the brackets. So we're going to get negative 0.02x squared plus
Negative
0.84. So that's because we rounded. Now I want to show you, I had kept the original number over here, 192 divided by 9216. That was the original number. I'm going to multiply that by 192. 4. Okay? So I actually got the number 4 when I multiplied it back. That's because I didn't round. So technically this is 4x. And this would be our standard form now. Y is equal to negative 0.02x squared plus 4x. Okay, so you looked at this term and we have to graph this, it said. You figured out, and sorry, remember this is equal to 0, it says in the question. So 0, it's very important that we keep that. It says it's equal to 0. We knew this was x plus 3, x plus 5. when it was factored. Now here's what's important. These are two terms. Think of them as a term each. And when they multiply by each other, they're going to equal 0. So in other words, one of them is going to be 0, or the other one's going to be 0. We got to figure out which ones, or what they're, if they were 0, what they would be. So I split this equation now, and I set each of them equal to 0. So in the first one, we have 0 is equal to x plus 3. And the other one, we have 0 is equal to x plus 5. Okay? So right now, what I'm finding is my x-intercepts. When I move 3 to the other side, I'm going to get negative 3 equals x. And when I move 5 to the other side, I'm going to get is equal to x. So my x-intercepts, the coordinates are negative 3 and 0, negative 5 and 0. And now I have two x-intercepts. Okay? Now we're going to try graphing that. So why don't you keep going there. Okay, question 3b. We need to create an equation out of this. So what's important is the information we have are the two zeros. We know the two coordinates. So let's actually write them out. Negative 1 and 0, and 4 and 0. In other words, these are our r and our s, right? From what we know. Now our factored form of the equation is y is equal to a x minus r x minus s, correct? Okay, so since that's our information, we're actually going to plug those in. And I want you to see what happens to the numbers when we actually plug them in. Okay, we'll get y is equal to ax minus, what's my r? Minus negative 1, right? Because our 1 is negative. And x minus, our number is 4. Okay. So what's going to happen to this is we're going to get x plus 1. Okay, and x minus 4. So in other words, kind of way of thinking of it, it kind of sometimes ends up as the opposite in there. Okay, so now that we have that, can you find the vertex with your r and your s? Okay, what formula would I use?
Axis and r.
AOS is equal to
R plus s
divided by 2. Great. Okay, so let's continue with that. Let's plug our numbers in. Our r is negative 1, and our s is 4, divided by 2. We're going to get 3 over 2, or 1.5. Now we have one of the numbers, our x value of our vertex. So we have the x value of 1.5. We got to find the y value. How can I find the y value?
Plugging in 1.5 into x.
Plugging 1.5 into x. Now the problem is we don't know what the a value is here. Sorry, I made a mistake. We actually didn't have to go this far. It doesn't matter. We still knew some stuff, which was good. They gave us the equation, like you said, which was y equals, what is it?
Negative x squared plus 3x plus 4.
Okay. So since they had given us that equation, first we take a common factor out of negative 1. Does that make sense? So we have x squared minus 3x plus 4. No, sorry, minus 4. Because we divided by negative 1. Is this making sense? And then when we factored it, what did you get?
We got x plus negative x minus 1 and x plus 4.
When they factor this, you would get x. So this should be actually x minus 4 and x plus 1, I think. Yeah, that's right. And that would be our a value we were looking at. And we factored this out. It would be x minus 4, x plus 1, once it's all factored. Does that make sense?
Yeah, I understand now.
Okay, question 6a. They've given us an equation. The population over time is equal to 14 t squared or time squared plus 650 times time plus 32,000. 6a asks us, now it says t is 0 in the year 2000 also. That's a note. T equals 0 in year 2000. They ask us, what will the population be in the year 2035, right? Now, what would my value of t be then in 2035?
2035.
Close. Are t 0 in the year 2000? So essentially, we're looking from the difference between 2000 and 2035. Yeah, that's right. Essentially, one way you could solve it is by just subtracting the two. So our t is 35, so we do p at 35 is equal to 1435 squared plus 650 35 squared plus 32,000. Does that make sense?
Yep.
Okay, that's A, and you would go about solving it that way. Now, I want to show you B, because B is trickier. I'm going to leave you up to A to solve from there, okay? Now, question B, because I want to get your notes here. 6B. It says, when will the population reach 50,000? In other words, when will P at T be 50,000? Okay? Now, what we got to do to solve this is we're actually going to have to factor this equation. Our equation was P at T was equal to 14T squared plus 650T plus 32,000, right? They want to know when will T, so what will T be when P at T is 50,000? So we actually replace P at T with 50,000 equal to 14T squared plus 650T, 32,000, okay? Now, in order for us to factor and solve, we actually need P at T to be 0. That's how we've been doing all of our factoring. So what I need to do, actually, is I need to move 50,000 over to the other side of the equation, so that I now have 0 is equal to 14 squared plus 50t plus 32,000 minus 50,000. I then solve our constant, right? T squared, 50t, 32,000, subtract 50,000, negative 18,000. Great. Minus 18,000. Now what I do is I need a factor. So I got to take out the common factor of 14. So we'll have t squared plus, now what is 650? I'm hoping 14 is a common factor. Oh no, it isn't a common factor. So we might have to actually take the number 2 out. Now, you've done factoring. So sorry, 14 wasn't a factor, but 2 will be. 325 plus 325t minus 9,000. Okay. Now, 7 is a prime number. This 325, can we take 7 out of it? No. Okay. Well, I did something weird there. Divide 7. Yeah. Okay, so there we go. We've taken out our common factor. I need to factor this. Okay. So do you remember you write the factors of the first term and the last term? Is that how your teacher does it? Yeah. So we're going to have a lot of factors because we have 9,000 here, right? Factors of 7 are going to be, yeah, so 1t and 7t. Right? Those are it. 9,000, well, we're going to have 1 and 9,000. 3 and something. 3 and 3,000. I think we're going to have to make a little room here. I'm going to really shift this over because we're going to need a lot of room. Okay. 3 and 3,000. 9 and 1,000. 10 and 900. We're going to end up with quite a few. So we need to really find one that's going to be close. It's probably going to be a factor of 5 somewhere, or 50. Let's try 50 and 9,000. So 9,000. Divide the number 50, 180. We're getting close. We're going to have to continuously find factors and then kind of work them out through factoring. Now, did they want us to use a graphing calculator? No. Essentially, we have to go through our factoring to solve it, and what we're going to find is, eventually, okay, is we're going to end up with, 2 and 2 factors that are equal to 0. Again, we'll have to split the brackets, and we'll put each equal to 0. And what you're going to find is you're going to get some negative value for x, and you're going to get some positive value for x. Okay, I just want to show the hypothetical. Now what's important about this, we have our negative and our positive. Would the population be 50,000?
Well, you have to pick which one it's going to be.
Yeah, which one makes sense? Would it make sense to the population to be 50,000 many years ago when it's only maybe 10,000 now? It would make more sense that it's a growing population, so we would take the positive number. Okay? So you'll end up with two answers. You got to pick which one is right. Now, do you understand the factoring? You know how to go through that? Yeah. Okay. So that's the idea.